Well, welcome. I'm JJ. Let's do an example problem. So we're asked in this one, let's determine the magnitude of F2, which is unknown right now, which would cause the resultant moment of F1 and F2 about point B to be equal to 250 Newton meters counterclockwise. So let's just jump in and go for it. This time we're summing moments up about point B with positive going counterclockwise, summing our moments about point B. Again, we always want to put into our equation what's the positive rotation assumption in here. And I wrote down point B instead of A in here just to really drill home. We don't have to do this about point A. We were told to do this at point B. We could do moments about any point we want to take a look at in here. So we're dealing with point B down here. So let's just go for that. This is equal to, I have two forces in here. So I can get both of them split into X and Y components. So for F1, we'd have a Y component right here, and an X component, we'll sketch that in here. For F2, we'll get it drawn now. We'd have an X component here, and a Y component right there. So I'll have to work with both of those. But let's just try that out. So if we deal with F1, let's get its X component in first. If we're drawing our circle around it, again, follow the arrow. It's going to point us to the left. As we leave the arrow, we'll make a circle around B. So we're coming in here. Our circle will drop down and around B. That went counterclockwise. So put this in as positive. So my Fx, even though it's in the negative x direction, I make a positive force or a positive moment out for that. So a positive 500 times my cosine to get the x component, cosine 75. That's my F1x, force 1 in the x direction. And I'll need to multiply that. I'm trying to get to point B, so it's my perpendicular distance up here from my arm, from that x component, dropping down to B. I'm going down 5 meters. So my perpendicular distance is 5. Anytime I have an x component, I should have a y distance. So a distance in the y here that I multiply by. F1x dy. Then we can check our y component for this. That y component goes down here. If I make my circle, dropping down, we go counterclockwise around B. So this one will also show up as positive in here. So plus F1y's moment. Again, even though the y component's negative, it's causing a counterclockwise rotation. We assume that was positive, so we put it in here as a positive. This is F1y would be 500 times the sine of our angle, sine 75, times, I need now what's my perpendicular distance from the y component over to B. That one's a little bit trickier because we aren't directly given that. But I know that from A to the left edge is 3 meters. From the left edge over to B is 4 meters. 4 minus 3 would give me that leftover distance in here is 1 meter. So 4 minus 3, or we could just write 1. But again, this is my F1y dx. My y component force always needs an x distance in there. That's not everything that's summing moment, though. We also would get moment from F2 up here. It's unknown for us, F2 is, but that's okay. It's what we're ultimately going to solve for in here. So let's get that one. F2's x component. I'm not going to draw it because it starts getting really cluttered. But if I circled here, going to the right, we would go clockwise around B. So I need to subtract this one out. Minus F2x will be my unknown F2 times the cosine of my 30-degree angle, cosine 30, times I need a y distance, 5 meters, to get from the line of action up here, my hand, down to B, times 5. Or again, documenting that, this is F2x dy. I'm just labeling these so we know where they're coming from. There's a lot of terms we're just throwing out there right now. You don't need to actually show that in your work for things, but it helps me out to show it a lot of times. But our last one would be that y component. If it goes up here, that would be a clockwise circle that it's going to make about point B. So I need to subtract this one out as well. Minus f2y will be f2 sine 30 times an x distance from the far left edge over to B, 4 meters, times 4. Again, we're getting a y component here, f2y, and an x distance, dx. Always a y component with an x distance. Always before, we were able just to sum this up for our basic moment problems. This one, though, we're given something. We're told this equals 250 Newton meters counterclockwise. So you can say this equals, and I'll put this in as positive, counterclockwise, and we assume counterclockwise was positive. So this all has to add up to 250. Down the road, we'll start using moment in equilibrium problems. For moment in equilibrium, everything has to add to 0. So you just say our sum of our moments is 0, and we can solve for an unknown. Here we're getting a moment out for that. That's okay. We can still work with that. But F2 is my only unknown. I can move everything over to the other side. I'm going to solve this out, and I would get that F2 is equal to 139.7 newtons. Which would be our answer there. We're not going to work through this part of it, but if we were asked to do moments about point A, what would we even need to include in there? So we had 4 pieces we put into this one. Would all 4 of those cause moment about point A on this problem? We should be able to say no to that. That if we look at that, if our force passes through a point, it's going to cause no moment. So F1 passes straight through A. Our perpendicular distance to the y and the x component on that is going to be 0 for us. So force times 0 gets us no moment out. For F2, the y component doesn't pass through here, but the x component would. It would pass straight through A. Or that x component causes no moment in there. Really, only F2y would be causing moment about point A. The point we choose to sum moments about really impacts things as well. But this was useful for you. Hit that like and subscribe. Let's get you an A with JJ.